July 11th, 1944, year 8:47 hours, near Saint-Lô, Normandy, France. Oberingenieur Hans Steiner crouched in the commander's cupola of his Tigerworth heavy tank, scanning the hedgerow country through Zeiss optics that could resolve details at 2,000 meters. The morning sun was already burning off the mist that clung to the sunken lanes and ancient field boundaries of the Norman bocage, revealing a landscape that seemed designed by some malevolent god to negate every advantage German armour possessed. These hedgerows, earthen banks topped with centuries-old vegetation, some rising 4 meters high, divided the countryside into a maze of small fields connected by narrow lanes, creating thousands of natural fortifications where visibility rarely exceeded 100 meters, and manoeuvre was nearly impossible. Steiner's Tiger sat at a crossroads, engine idling with that distinctive deep rumble of the Maybach HL-230, its long 36 gun traversing slowly as the gunner searched for targets. The tank was magnificent, a masterpiece of German engineering, 60 tons of armour and firepower, frontal armour 100mm thick that no Allied tank gun could penetrate at combat ranges, a main gun that could destroy any enemy vehicle at distances where return fire was impossible. Steiner had trained on this machine for months, had studied its systems with the thoroughness that German technical education demanded, understood its capabilities and limitations with engineer's precision. He knew that in open terrain, with clear fields of fire and room to manoeuvre, the Tiger was virtually invincible. He also knew, with growing apprehension, that this hedgerow country was not open terrain. The radio crackled, terse reports from other vehicles in his company. 3rd Platoon had lost a Panzer IV to a concealed American tank destroyer. 1st Platoon was bogged down in a sunken lane, unable to advance or retreat. 2nd Platoon, his platoon, was supposed to clear this crossroads and push south, toward American positions, but the mission assumed the Americans would fight conventionally, would meet German armour in the open where superior German optics and firepower could dominate. Instead, the Americans were fighting like partisans, hiding in hedgerows, ambushing from concealment, refusing decisive engagement. Through his optics, Steiner saw nothing. No movement, no dust, no glint of metal that would betray enemy positions. Just hedgerows and fields and the occasional stone farmhouse, all apparently empty, all potentially deadly. The silence was worse than combat. In Russia, you could see the enemy, could identify threats and engage them. Here, the enemy was invisible until the moment of contact, and contact meant a Sherman materializing from behind a hedgerow at 70 meters, firing into the Tiger's thinner side armour, then reversing back into cover before German guns could respond. The Americans were turning German tactical doctrine inside out, negating technological superiority through terrain exploitation and tactics that German training had not anticipated. The sound came first, not the high-velocity crack of an anti-tank gun, but something else, something mechanical and rhythmic. Engine noise, multiple engines, diesel engines by their pitch. The sound was coming from beyond the hedgerow to his left, perhaps 50 meters away, impossible to see through the dense vegetation. Steiner felt his pulse quicken. Multiple engines meant multiple vehicles, American armour certainly, but how many? Where exactly? What type? His gunner traversed left, but there was nothing to aim at except hedgerow, and firing blindly would only reveal his position without guaranteed effect. Then the hedgerow exploded, not from shell fire but from within, as an American Sherman tank burst through the earthen bank in eruption of dirt and vegetation, its bow pointed directly at Steiner's Tiger. Before his gunner could react, the Sherman fired, a 75mm round that struck the Tiger's turret at a bleak angle, ricocheting off the heavy armour with shower of sparks but doing no damage. The Sherman was already reversing, backing into the hedgerow, disappearing into cover. Steiner's gunner fired back. The 80mm guns roared, deafening even through the tank's armour, but the shot went high, missing the retreating Sherman, punching through empty air where target had been seconds before. Before Steiner could process what had happened, another Sherman burst through the hedgerow 50 meters to his right. A different location, a different angle, firing once at the Tiger's side, then reversing back into concealment. This shot struck armour at better angle, penetrating the thinner side plating, killing his loader and wounding his radio operator, filling the crew compartment with smoke and blood and the acrid smell of burning propellant. Fire alarms screamed. Steiner ordered bail out, and his surviving crew scrambled from the stricken tank, taking cover in a drainage ditch as the Tiger's ammunition began cooking off, secondary explosions turning the pride of German engineering into funeral pyre. From the ditch, Steiner watched American tactics unfold with horrible clarity. The Shermans were not engaging individually, but in coordinated groups. One tank would create distraction while others maneuvered into flanking positions, multiple vehicles attacking simultaneously from different directions, exploiting the Tiger's slow turret traverse and limited situational awareness. When German tanks tried to respond, tried to bring superior firepower to bear, the Shermans simply reversed into cover, disappeared behind hedgerows that German rounds could not penetrate, then re-emerged at different locations. The Americans were using the terrain as weapon, turning the bocage's restrictions into advantages, fighting a mobile ambush war that negated every technical superiority German armour possessed. This was not how tank warfare was supposed to work. Steiner had studied Guderian, had absorbed the principles of Panzer doctrine, manoeuvre, concentration of force, decisive engagement. He had trained in Poland and France, where German armour had achieved legendary victories through superior tactics and technology. But the Americans were not fighting the way enemies were supposed to fight. They were not accepting battle on German terms. They were creating conditions where German advantages became irrelevant and German weaknesses were systematically exploited. And they were doing this not with wonder weapons or technical superiority, but with simple field expedients, welding steel tusks to their Sherman's bows to break through hedgerows, coordinating through radio communications, attacking in groups rather than individually, accepting losses as temporary setbacks rather than decisive defeats. What Hans Steiner witnessed in the hedgerows of Normandy was the collision of two fundamentally different approaches to armoured warfare, the invalidation of assumptions that had guided German tank development since the late 1930s, and the demonstration that tactical flexibility and numerical superiority could overcome technical excellence when terrain and doctrine were properly aligned. The Sherman tank that destroyed his Tiger was, by German engineering standards, a thoroughly mediocre machine, under-armoured, under-gunned, prone to catching fire when penetrated. German tankers called it the Tommy Cooker, or Ronson, after the cigarette lighter that advertised light's first time every time. On paper, comparing specifications, the Sherman should not have been able to defeat a Tiger under any circumstances. In the bocage, specifications meant nothing. The M4 Sherman medium tank entered American service in 1942 as compromise design that prioritized production efficiency, mechanical reliability, and crew ergonomics over armour protection and firepower. Weighing 30 tons compared to the Tiger's 60, carrying a 75mm gun that could barely penetrate Tiger frontal armour even at point-blank range, protected by armour that German 80mm guns could pierce at 2,000 metres, the Sherman appeared to be death trap when facing German heavy armour. American tank crews knew this, grimly aware that engaging Tigers or Panthers required numerical superiority and tactical creativity because they could not win through direct firepower exchange. But the Sherman possessed advantages that were less obvious, but ultimately decisive. It was mechanically reliable. The Continental R975 radial engine, adapted from aircraft use, was well developed and robust. It was producible. American factories built nearly 50,000 Shermans during the war, compared to approximately 1,400 Tigers. It was maintainable. Standardized parts and simple systems meant that combat damage could often be repaired quickly. It was ergonomic. The 5-man crew had adequate space and good visibility, reducing fatigue and improving combat effectiveness. Most critically, it was abundant. When Shermans were destroyed, replacements arrived within days, sometimes hours, while German tank losses often could not be replaced at all. American tactical doctrine evolved to exploit these characteristics while minimizing Sherman vulnerabilities. Rather than seeking one-on-one duels where German technical superiority would dominate, American armour operated in coordinated groups, typically 4 or 5 Shermans working together, using radio communication to coordinate movements, with some tanks providing suppressive fire while others manoeuvred for flank shots. The tactics were not brilliant or innovative in theoretical sense. They were practical application of numerical superiority and coordination, accepting that some tanks would be lost, but trusting that concentrated fire from multiple directions would eventually achieve kills. The hedgerow country of Normandy forced further tactical evolution. The bocage's tight confines and limited visibility made traditional armoured tactics nearly impossible. There was no room for sweeping manoeuvres, no long-range firing positions where German optics and guns could dominate. Instead, combat occurred at ranges where even the Sherman's 75mm gun could be effective, where ambush was more important than armour thickness, where the ability to break through hedgerows and disappear quickly was more valuable than top speed on roads. American combat engineers and tank crews responded with field modification that epitomised American approach to warfare, the hedgerow cutter, called the Rhino device. Fabricated from German beach obstacles captured on D-Day, these steel tusks were welded to Sherman bows, allowing tanks to punch through hedgerows rather than climbing over them and exposing vulnerable belly armour. The modification was not designed by engineers at ordnance departments. It was invented by a sergeant in the 2nd Armoured Division, tested in combat, and then rapidly adopted across American armoured units. Within weeks, hundreds of Shermans were equipped with the devices, and American tactical doctrine shifted to exploit the new capability. Hans Steiner understood none of this context as he huddled in the drainage ditch watching his Tiger burn. What he understood was that everything he had been taught about armoured warfare was failing in practice. The Tiger's technical superiority meant nothing when American tanks attacked from concealment at 50 metres, when 5 Shermans could concentrate fire on one Tiger from multiple angles, when the bocage terrain negated every advantage German engineering had built into the design. The Americans were not trying to match German technical capabilities. They were changing the terms of engagement entirely, fighting a different kind of war where numbers and tactical flexibility defeated quality and firepower. Over the following days, as Steiner was evacuated to hospital to treat his wounds, then reassigned to training duties, the pattern became undeniable through reports filtering back from Normandy. German armoured units were suffering unsustainable losses, not through being outfought in open battle, which rarely occurred, but through systematic attrition in conditions where American advantages were maximised and German advantages were minimised. The Americans accepted losses that German commanders would have considered catastrophic. An American armoured division might lose 30 or 40 tanks in a day's fighting, but replacements arrived from depots within hours. A German Panzer division losing 10 tanks in a day was significantly degraded, because those 10 tanks might take weeks to replace if they could be replaced at all. The mathematics were pitiless. Germany began the Normandy campaign with approximately 1,500 tanks and assault guns. America and Britain landed with approximately 3,000 tanks, with hundreds more arriving weekly as production continued and logistics delivered new vehicles to France. When German tanks were destroyed, they were gone. Factories in Germany were being bombed systematically, raw materials were scarce, experienced workers were being conscripted, production was declining. When American tanks were destroyed, they were replaced. Factories in Detroit and Pittsburgh ran multiple shifts. Materials arrived from across the American continent. Production was increasing despite years of warfare. Steiner tried to communicate these realities to students at the training facility where he was assigned, young men fresh from conscription who had minimal technical knowledge and even less combat experience. He attempted to teach them that the Sherman was not the contemptible machine German propaganda portrayed, that American tankers were not cowards or incompetents, that numbers and coordination and mechanical reliability were legitimate advantages that could overcome superior armour and firepower. But his lectures conflicted with official doctrine, with propaganda that insisted on German superiority, with institutional resistance to acknowledging that the enemy might be doing anything right. The sound became symbolic in Steiner's memory, and later in his writings. The sound of multiple engines working in coordination, the distinctive pitch of American radial engines that announced Sherman presence, the mechanical chorus that signified numbers that German forces could not match. In Russia, tank combat had often been solitary predator encounters, single German tanks stalking single Soviet tanks, relying on superior optics and guns. In Normandy, the engine sound was always plural, always multiple vehicles operating together, coordinated through radio communications that allowed tactical flexibility German units rarely achieved. He wrote in his journal during this period, "We built the finest tanks in the world. Each Tiger is masterpiece of engineering, powerful gun, thick armour, precision optics, sophisticated systems. But the Americans built adequate tanks in overwhelming numbers. They welded scrap metal to their bows to break through hedgerows. They attacked in groups of 5 against our 1s. They accepted losses we would consider catastrophic and simply brought up more tanks. This is not how war was supposed to be fought. This is industrial process applied to combat, and we are losing to the process because we cannot match their production, cannot replace our losses, cannot adapt as quickly to new conditions. Our technical excellence has become strategic liability because it is too expensive, too slow to produce, too difficult to maintain under field conditions. In September 1944, Steiner was transferred to the Western Front Staff, assigned to compile reports on combat effectiveness and tactical lessons. The assignment provided access to after-action reports from across the front, and the pattern was consistent. German armour was achieving impressive kill ratios, often destroying 3 or 4 American tanks for each German loss. But the Americans kept coming, and the kill ratios meant nothing when German losses could not be replaced. An American armoured division that lost 60 tanks in heavy fighting would be back to full strength within a week. A German Panzer division that lost 20 tanks would operate under strength for months. The reports also documented tactical evolution that Steiner found both impressive and disturbing. American armour was learning, systematically and rapidly. Early in the Normandy campaign, Sherman crews had often attacked individually, suffered heavy losses, fallen back. Within weeks they were coordinating group tactics. By August, they were conducting complex combined arms operations, integrating armour with infantry and artillery and air support. By September, they were exploiting German weaknesses ruthlessly, isolating German strongpoints, calling in overwhelming firepower, bypassing resistance rather than engaging directly. The learning curve was steep and institutional, with lessons identified at tactical level being rapidly disseminated to training commands and incorporated into doctrine. German tactical evolution was slower and more localized. Individual commanders developed effective responses to American tactics, but these innovations often died with the commanders who created them, or were lost when units were destroyed. The institutional mechanisms for capturing lessons and disseminating them broadly did not function effectively under the pressure of systematic retreat and collapsing logistics. Germany's initial tactical superiority, built on years of combat experience, was being eroded as veteran units were destroyed and replaced with hastily trained formations that lacked the institutional knowledge their predecessors possessed. Steiner attempted to quantify the disparity in his official reports. American armoured forces in France included approximately 16,000 tanks by September 1944. German forces opposing them included approximately 1,500 tanks and assault guns. The numerical ratio was roughly 10-1. But the disparity was actually greater than numbers suggested, because American tanks were supported by vast logistics networks that kept them operational, while German tanks often sat immobile for lack of fuel or spare parts. Operational readiness rates for American armour typically exceeded 80%. German readiness rates by late 1944 had fallen below 50%. A 10-1 numerical advantage combined with 2-1 readiness advantage created effective force disparity of 20-1. Against such odds, German tactical excellence was inadequate. A German tank crew that destroyed 5 American tanks before being destroyed themselves, and such achievements occurred regularly, was still contributing to German defeat because the 5 American tanks would be replaced while the German tank would not. The mathematics were inescapable, and Steiner documented them meticulously, though he knew his reports would be ignored or suppressed because they contradicted the narrative of German superiority that propaganda required. In November 1944, Steiner was captured during the Allied breakthrough in Alsace. His command vehicle was hit by American artillery, he was wounded by shell fragments, and when he regained consciousness he was in American custody being evacuated to a field hospital. The treatment he received was professional, almost routine. Wounds cleaned and bandaged, morphine for pain, plasma transfusion to treat shock, evacuation to surgical facility and ambulance equipped with sophisticated medical equipment. The medical care was better than what he had received in German military hospitals, and he reflected bitterly on the disparity. America could afford to treat captured enemies better than Germany treated its own soldiers, because American resources were that abundant. The POW camps continued the pattern. Steiner was sent to a camp in Britain, processed through administrative procedures that were bureaucratic but efficient, assigned to a barracks that was plain but weatherproof, provided with food that was simple but adequate. 3 meals daily, more than adequate to maintain health. Medical care available. male privileges granted, recreation facilities provided. The treatment was not luxurious, but it met Geneva Convention standards scrupulously, even though Germany did not always reciprocate for Allied prisoners in German custody. What struck Steiner during captivity was the casual abundance of everything American. The guards had more equipment than they needed, multiple uniforms, good boots, radios, vehicles. The food served to prisoners came in quantities that allowed waste, because production exceeded requirements by comfortable margins. Supply trucks arrived constantly, delivering materials that were stacked in warehouses until needed. Everything operated with redundancy, backup systems for critical equipment, spare parts stored in abundance, multiple supply routes so that interruption of one did not compromise operations. This was the military expression of American economic philosophy. Produce more than needed, accept waste as inevitable, prioritize reliability over efficiency. The sound of engines continued as acoustic backdrop to camp life. Steiner could hear vehicles on nearby roads, trucks delivering supplies, military convoys, civilian traffic. The sound was constant, normalized, unremarkable to the Americans but striking to German prisoners who had spent years under increasing scarcity. The engine sound represented mobility and abundance, the capacity to move people and goods freely, the industrial production that generated surplus. In Germany by late 1944, civilian vehicle traffic had essentially ceased for lack of fuel. In Britain, even under wartime conditions, vehicles operated constantly, powered by fuel supplies that seemed inexhaustible. Steiner discussed these observations with other German POWs, technical specialists and officers who had fought in various theatres. The consensus was grim but clear. Germany had lost the war of production. The technical quality of German equipment was often superior to American equivalents. The Tiger was a better tank than the Sherman. The MG-42 was a better machine gun than the Browning 30 caliber. The 80mm was a better anti-tank gun than the 57mm. But technical quality could not overcome numerical quantity when the disparity was as extreme as America could generate. And technical quality came at costs that made production difficult. Sophisticated systems were slow to manufacture, expensive in materials, difficult to maintain in field conditions. American approach was exactly opposite. Simple systems that were easy to manufacture, tolerant of battlefield conditions, maintainable by minimally trained mechanics. The Sherman was not a sophisticated tank, but it was reliable. Its radial engine, its bogie suspension, its relatively simple armour configuration, all these features made production faster and maintenance easier. When Shermans broke down, crews could often repair them with minimal support. When Tigers broke down, they often required specialised equipment and trained technicians who were increasingly unavailable as German logistics collapsed. The philosophical contrast extended beyond hardware to the nature of military organisation. American forces operated on principles of decentralisation. Small unit leaders were expected to make tactical decisions, adapt to circumstances, exercise initiative within broad mission parameters. German forces emphasised centralised command. Detailed orders issued from higher headquarters, strict chains of command, limited tactical flexibility at junior levels. The American approach was more resilient to disruption. When communication failed or commanders were killed, units could continue operating autonomously. The German approach was more efficient under perfect conditions but fragile when conditions deviated from plan. Steiner watched American military personnel in the camp and noticed this cultural difference manifest in small ways. Guards would question orders that seemed illogical, discuss alternative approaches with their sergeants, collectively problem-solve rather than simply executing directives. This would have been insubordination in German military culture, but it seemed to function effectively for Americans, generating practical solutions to operational problems. The apparent indiscipline was actually a form of distributed intelligence, using collective knowledge rather than relying solely on hierarchical authority. In 1946, after Germany's surrender, Steiner was repatriated to a homeland divided and occupied. He found work as technical translator for American military government, then as engineer for German industries rebuilding under Allied supervision. His technical education and his English, learned during captivity, made him valuable in facilitating technology transfer from American companies to German manufacturers. The work was ironic, helping Germany adopt American industrial methods, applying lessons about standardization and production efficiency that American military success had demonstrated. The Marshall Plan, beginning in 1948, brought massive American aid to Western Europe, including West Germany. Steiner worked on projects funded by Marshall Plan assistance, helping rebuild factories that would produce civilian vehicles using methods adapted from American automotive industry. The assistance was strategic, containing Soviet expansion, creating markets for American exports, but it was also generous by historical standards, helping former enemies rebuild rather than simply extracting reparations. The generosity reflected the same abundance that had won the war. America could afford to rebuild Europe because American industrial capacity was that vast. In 1958, Steiner was interviewed by American military historians researching German perspectives on armoured warfare. The interview covered his experiences from training through combat to captivity, but focused particularly on the tactical lessons from Normandy and why German armour, technically superior, had been defeated by American forces. The historians were particularly interested in the moment Steiner realised that German armour doctrine was failing. His answer was specific. When I saw American Shermans break through hedgerows using improvised steel cutters, attack my Tiger from multiple directions simultaneously, and disappear back into cover before we could effectively respond, that was the moment I understood that technical superiority was insufficient. The Americans had adapted to terrain and tactical conditions faster than we could respond. They were willing to accept losses. That single engagement cost them probably 3 tanks, but they achieved their objective, which was destroying my Tiger. 3 Shermans for 1 Tiger sounds like German victory, but when the Americans could replace their 3 tanks overnight, and we could not replace our 1 tank at all, the arithmetic favoured them. They were fighting war of attrition, and they possessed resources to win through attrition. We were fighting war of quality, but our quality could not be sustained against their quantity. The historians pressed him on whether better German tactics could have changed outcomes. Steiner was emphatic. No, better tactics could have improved kill ratios, could have delayed defeat, but could not have changed fundamental mathematics. America was producing 7,000 tanks per year at peak production. Germany was producing perhaps 2,000 tanks and assault guns per year by 1944, and that number was declining due to bombing and material shortages. Even if German tanks achieved 4-to-1 or 5-to-1 kill ratios, which we sometimes did, we were still losing the attrition competition. The Americans understood this. They built adequate tanks in overwhelming numbers, developed tactics that exploited their numerical superiority, and simply ground us down through systematic application of resources we could not match. The interview concluded with historians asking about symbolic objects or sounds that captured Steiner's experience. He returned immediately to the engine sound. The sound of multiple Sherman engines coordinating an attack. Not a single engine. We could handle single tanks. But multiple engines, attacking simultaneously from different directions, the sound multiplying as more tanks arrived. That sound represented everything about American approach to warfare that we failed to anticipate. They did not rely on individual excellence. They relied on coordinated mediocrity at overwhelming scale. Their individual tanks were mediocre by our standards, but 5 mediocre tanks attacking simultaneously defeated 1 excellent tank, and they always had 5 tanks available, while we struggled to maintain one. The sound of those engines in coordination was the sound of our defeat. The acoustic proof that quantity properly organised was superior to quality inadequately supported. Hans Steiner lived until 1989, long enough to see German reunification discussions beginning. He spent his final decades as consultant to automotive and engineering firms, teaching production efficiency and quality control methods that synthesized German precision with American mass production philosophy. He remained conflicted about his war service, proud of his technical competence, ashamed of the regime he had served, troubled by the lives lost in cause he came to recognize as evil. His journals and letters, donated to archives after his death, provide rare technical perspective on German armour warfare and its systematic defeat by American forces that fought smarter rather than better. One letter, written to a former comrade in 1975, serves as epitaph. We built the Tigers and Panthers, magnificent machines that represented the apex of our engineering culture. We trained elite crews, developed sophisticated tactics, achieved remarkable technical successes, but we lost to Americans driving mass-produced Shermans that our engineers considered inferior. Why? Because the Americans understood something we did not, that modern war is industrial process. An industrial process requires reliable systems produced at scale, not perfect machines produced in insufficient numbers. Their Sherman was reliable. Their logistics kept it operational. Their doctrine used it effectively. Their industry produced it in thousands. Our Tiger was superior in every technical specification, but could not be produced fast enough, maintained easily enough, or replaced quickly enough. We optimized for perfection. They optimized for production. Production won. This is not the lesson German military tradition wanted to learn, but it is the lesson our defeat teaches. In modern war, adequate systems produced abundantly defeat perfect systems produced scarcely, as surely as those Sherman crews defeated my Tiger through simple tactics that exploited our weaknesses rather than matching our strengths. The story of Hans Steiner and the Sherman crews who outsmarted German armour represents more than tactical evolution or battlefield innovation. It represents the collision between two philosophies of military excellence, one emphasizing technical perfection and individual skill, the other emphasizing systematic adequacy and coordinated action. German armour doctrine built on centuries of military tradition that valued quality over quantity, that trusted in superior training and equipment to overcome numerical disadvantages. American armour doctrine built on industrial culture that valued production efficiency, that accepted adequate performance when produced at scale, that trusted in systematic coordination to generate collective capabilities exceeding individual excellence. The deeper lesson concerns the relationship between industrial capacity and military effectiveness. Germany's technical sophistication in armour design was real. The Tiger, the Panther, the Ferdinand all represented genuine engineering achievements that showcased German expertise in metallurgy, optics, and mechanical systems. But this sophistication was strategic liability when it prevented adequate production, when it created maintenance difficulties under field conditions, when it consumed resources that could have produced greater numbers of simpler vehicles. American embrace of adequate but producible design philosophy generated overwhelming numerical superiority that tactical brilliance could not overcome. The sound of engines that haunted Steiner's memory, the coordinated mechanical chorus of multiple Shermans attacking simultaneously, was more than mere noise. It was information about power and systems and industrial foundations of modern warfare. Each engine represented supply chains that delivered fuel, maintenance networks that kept vehicles operational, training programs that produced adequate crews, industrial systems that manufactured and replaced equipment faster than combat could destroy it. The multiplication of engine sounds represented multiplication of force, the systematic application of adequate capabilities at overwhelming scale. This was what German armour encountered in Normandy and across the Western Front. Not technical superiority but systematic superiority. Not better tanks but more tanks employed more flexibly. Not exceptional soldiers but adequate soldiers, supported so abundantly that adequacy became decisive. The Americans did not try to build Tigers. They built Shermans in quantities that made Tiger technical advantages irrelevant, developed tactics that exploited Sherman numbers, created logistics that kept Shermans operational, established production that replaced Sherman losses faster than combat could inflict them. They fought smarter by fighting simpler, by reducing the problem to mathematics that favoured the side with greater resources, by creating conditions where German excellence was insufficient and American abundance was overwhelming. The lesson remains carved in hedgerows of Normandy, written in after-action reports documenting kill ratios that meant nothing strategically, preserved in the journals of German engineers who witnessed their technical masterpieces defeated by mechanical coordination and numerical superiority. Simple field tactics, attacking from multiple directions using terrain as weapon, accepting losses while maintaining pressure, defeated sophisticated equipment when the simple tactics could be executed by overwhelming numbers of adequate platforms. The arithmetic of steel was pitiless. 5 times mediocre equals 1 times excellent when both sides fight to destruction, and only one side could afford to fight to destruction repeatedly. The Americans could. The Germans could not. That disparity, more than any tactical innovation or technical specification, determined outcomes in the steel arithmetic of armoured warfare. Hans Steiner understood this through direct experience, watching his Tiger burn after being ambushed by coordinated Shermans, hearing the engine sound that announced American numbers, experiencing the abundance of captivity that revealed the industrial foundations of American military power. The understanding came slowly, resisted by training and pride, but became undeniable through accumulated evidence. The Shermans won not by being better tanks, but by being adequate tanks produced overwhelmingly, employed systematically, supported abundantly. That was the lesson written in the sound of coordinated engines, in the mathematics of replacement rates, in the systematic defeat of technical excellence by organised adequacy, a lesson about the nature of modern war that German military tradition had not prepared him to learn, but that battlefield reality taught with absolute authority.